In the last video, we talked about central tendency, where we basically explained three different measures of central tendency: mean, median, and mode. In this video, we will talk about measures of variability. Before getting started with measures of variability, let us first explain what is the limitation of measures of central tendency and particularly mean. So, if you remember, we calculated mean by summing the values of the observations and dividing it by the total number of observations. So let's take an example. Suppose we do have customer and their income. We have five customers, 1, 2, 3, 4, and 5. Everyone has income of 10. So if you will sum it up and divide it by total number of observations, this will give you an average of 10. While there is another data, customer and again income. Here also there are five customers, 1, 2, 3, 4, and 5. And the income that these customers have is 5, 5, 10, 15, 15, which again, if you will add up, will come out to be 50. And if you will divide it by the number of the observations, it will again come out to be 10. So as you can see, in both the cases, we do have averages equal. In both the cases, we do get average equal to 10. But if you will look at the distribution of the data, it's very, very different. In one case, everyone have an equal income of 10, while in another case, there is some variation in the income. So what we are trying to say here is, while central tendency is a very good measure to give you a single number which tells where your data is located, but it will not perform really well to tell how dispersed the data is. It will not tell you that how dispersed the data is. When I say dispersed, I am basically saying how much variation there is in the data. Because if you will see, in the first case, there is zero variation, while in another case, there is some variation in the data. So the measures of central tendency don't answer us all these questions. Oh, so to solve this particular problem, we do have another measure which are called measures of dispersion. And in that, we first of all we will talk about range. Range is nothing but maximum value minus minimum value. That is range. For example, score in any particular test can range from 1 to 10, and there are many students who have basically given this test, but most of the students have secured the score of 8 or 9. There is only once, or not 8 or 9, basically 5 to 6. And there is only one student who have secured the score of 10, and there is only one student who secured the score of 2. Now, based on the range or the formula of range, what we will do is we will subtract maximum value attained, which is 9, minus 2, which is the minimum value, and we will get the value 7. And we will say that the range is 7, and range is a big number based on minimum or maximum value. So there is some variability. But if you will look at the data or the trend, that is not the case. Most of the observations are still located here. While because of some extreme values, we are getting such a high range. So while range gives you a quick snapshot of how the dispersion looks like, but this is not a reliable measure. Why? Because range is impacted by extreme values. A slightly better approach of finding the dispersion is second measure, which is called interquartile range. In interquartile range, what we are doing is we are subtracting P75 value and P25 value. So P75 minus P25 is basically your interquartile range. Now, what is P75 and P25? If you remember in the last class, we talked about median, which splits the data into two equal halves. The point where data gets split into two equal halves is called median. Another name of median is P50, that is percentile 50. What this tells you is 50% of observations lies below this value, P50 value. Similarly, P75 will tell you 75% of observations lie below this value. And P25 tells you that 25% observations lie below this value, P25 value. Now suppose you have a distribution. This is your P25 and below this your 25% of observations are located. For example, this value is 9 and this is your P75 and here 75% observations are located below this value, and suppose this P75 value is 19. Then what we are saying is interquartile range is 19 minus 9, which is equal to 10. And within this range of 10 points, our middle 50% observations are located. How? Because P75 is telling you 75% observations towards left and P25 is telling you 25% observations toward left. So 75 minus 25 will give you 50% observations in this bucket. So interquartile range is basically telling you between which points or what is the range within which middle 50% observations are located. Now, how to interpret interquartile range? If interquartile range is high, then we are saying that 75% data minus 25% data, which is again middle 50% data, is located between, for example, 100 and 10. While if IQR is low, we will say middle 50% data is located between 100 and 90. In this case, there is low variability in the data, while in this case, there is high variability in the data. There is lot of variation in the data points. It ranges from 10 to 100, the middle 50 points, while in this case, it ranges only from 90 to 100, the middle 50% data points. So that's how we are going to interpret interquartile range. I hope you like the video. In case of any questions, Please feel free to add your questions in the comment section, and please like, share, and subscribe. Thank you.